We're going to talk about pressure measuring devices and things to consider. So one is called a manometer. Okay, it's spelled Manometer. Manometer. Okay, and basically, it's used to usually measure the pressure of a gas inside a container. So you'd have some sort of container with a connecting port on it, and this has the gas, and it's got gas at some pressure that we're trying to figure out. Now the thing we know is we know atmospheric pressure. You know, the molecules out here, that's at 1 atm, or 1 times 10 to the fifth pascals. And the way we can use that reference is we can connect a tube that goes down and up like that, and that tube can have fluid in it. All right. Now this side of the tube is open, so the fluid would be open to the atmospheric pressure, which means right there the pressure is also 1 atmosphere. Okay. So if the pressure in the gas is larger than atmospheric pressure, it's going to push this fluid such that there is a height difference here. Okay. So the difference in pressure is going to be from the hydrostatic pressure in this column, which is the difference from the top of the opening to where the other side ends. Because we know that the pressure right here is the same as the pressure right here. Okay, and so this is a rho GH, where rho is the density of the liquid. I'll emphasize that, it's the liquid in the tube. Okay, so which means if the top of this column is at 1 atmosphere and the bottom is rho GH higher pressure, then we can say that P pressure in the gas is equal to 1 atmosphere plus rho GH. Again, remembering that's the density in the liquid. Okay, so that's one way of measuring the pressure of a gas. Now, there's another way called a barometer. This is used in weather because this is used to directly measure the air pressure. And, you know, some days the pressure actually gets bigger or smaller depending on different weather conditions. So it's called a barometer. And you can create one fairly simply. You just need a tube, like a closed, like even a cup would do it. But you take a dish that's got liquid in it, and then you take a tube full of liquid. So you make sure it's full, and you dump it or turn it upside down so that it's inside the liquid. And in doing so, some of the liquid's going to run out. So you'll get this little vacuum at the top. Okay, this space right here, that's a vacuum. There is no air in there because we had made sure the tube was full of water before we inverted it. Okay, and so because of the hydrostatic pressure, some of that would flow out. So we know that right there means the pressure at that point equals 0. Okay, so I'm going to clean up this line here because now we have the liquid is all the way filling all this space here. Okay, well, we know that out here this is P atmosphere. So I'm going to write P atmosphere instead of 1 atmosphere because this is how we measure the small differences at different locations from sea level to on top of a mountain or in different weather patterns where the pressure actually changes somewhat from atmospheric. Okay, it doesn't hurt our assumption that generally around us it's 1 atmosphere. Okay, so how do we find then the atmospheric pressure with a barometer? Well, we know that at this level, okay, at that level, that is atmospheric pressure because it's at the same level which is open to the outside. We know that the space at the top is at 0 pressure, which means we have this height again of rho GH. Okay, and so the atmospheric pressure is pushing down and trying to fill the tube. The hydrostatic pressure is trying to hold that water up, and those are the same. So that means we know that rho atm, the atmospheric pressure, or sorry, that's a P. P, the atmospheric pressure, must be equal to rho GH. So that's how a barometer works.